these webinars happen. And if you have any questions, Andy will likewise be joining us for the Q&A portion of the webinar at the end. Now, let me introduce to you our speaker for the webinar series, Dr. Peter Aiken. Peter is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. He has written dozens of articles and 12 books. Peter has experience with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. And with that, let me turn everything over to Peter to get his presentation started. Hello and welcome.
Welcome to you, Shannon. And Andy, thank you for a great intro. I'll do a quick little plug here too. Just my publisher would get mad at me if I didn't say the books are on special sale at the moment at my website called anythingawesome.com, but that's not what you're here for today. And there are a lot of you here. This is wonderful. We have people from New Zealand all the way around the world, and it's great. And I'm looking forward to a real good discussion on this. So let's jump right back in as we go with the program here. I'm going to give you an introduction to modeling data for starters. Then we're going to talk about the three types: conceptual, logical, and physical modeling. And then, of course, we'll get to some takeaways and references as we go through the overall process, learning how all this works. So let's just dive in here. And I want to start out by saying there's lots and lots at the end here for more if you're interested in this topic to go further. But one place to start for sure is my colleague and friend David Hay, who has a terrific book where he dives into these things in a lot more detail than perhaps we have the opportunity to do right here. That said, let's start out with just sort of the data tsunami bit that everybody has to do. There's a wonderful company out there called domo.com that does a great job of talking about how much data is occurring. And these numbers are fabulous if you need to relay them to somebody in your management. Again, if you're in YouTube, working in YouTube, you better manage your data well enough so that users are able to stream almost 700 hours of YouTube videos for every minute of the entire day for the entirety of 2021. And this leaves us with a very large pile of data. If we go sort of pre-digital age versus post-digital age, you'll see that the amount of data that we're working with has largely been created in the last 2 years. And what that leaves us with is a situation where we have an incredible demand in terms of trying to analyze all this data and figure out what it means. And yet we're not even close. All of us that are working in the area have been working as hard as we can, but you can see there is still an enormous gap between the amount of data that we have out there and the amount of data analysis capabilities that we'd like to have. And of course, if you don't understand what your data is, or you don't do things with it in a structured fashion, and I'm going to give you a little different word for that, if you let everybody do data on their own, you will end up with this, which is a mess. And it looks like a hoarder. It probably is relevant to say a hoarder bit about this. 80% of the data in your organization is redundant, obsolete, or trivial. And that's an incredible statistic on this. You have to have the idea that we have a shared understanding of this, and data models are how you achieve that shared understanding. All of your organizations have conceptual data arrangements from the business, the process, the systems, the security, the technical, the data and information, and several other types of architectures that you have. You have them. The question is, do you and the rest of the organization understand them? And if you understand them, that's great. However, if they are not documented, they cannot be useful to others. And if they can't be useful to others, the idea that understanding a data model is that we understand it as a set of requirements that we are specifying for the data components of one or more systems that we're working with. But more importantly, that shared understanding occurs between humans. It's literally the same thing as musicians singing off the same sheet of paper, but we also have to make sure that the systems understand this in the exact same fashion. Now, modeling addresses something I call data debt. You'll see this term more and more, and it's the idea that if you haven't been paying attention, if you haven't been modeling your data, if you haven't been following best practices around this, you need to sort of get back to zero and then move forward in order to move forward. Now, let's do a quick model of what data and information and intelligence are. And I'm going to start out with a little story that starts out with the number 42. And if you're a fan of Douglas Adams, you'll know that 42 is the answer to life, the universe, and everything in the Hitchhiker's Guide to the Universe. Also, obviously, it is Jackie Robinson's jersey number. And if you take 42 and add 21 to it, you'll have the number of years I have been on the planet Earth, clearly making me old enough to consume adult beverages, at least in my state of Virginia. What I've done there, of course, very briefly, is put together a series of meanings around a fact. The fact is 42. The meanings are, what is the meaning of life? What was Jackie Robinson's jersey number? And is Peter old enough to drink? Each fact combines one or more meanings, and each fact and meaning combination is a data. I've already mentioned the rot factor. 80% of your data is redundant, obsolete, or trivial. So you need to understand and distinguish between data and useful data for starters. In addition to that, we can also objectively characterize the difference between data and information, as information is data that has been requested in one form or another. And by adding that simple rule and its objective criteria, you can see we can follow up with Dan Morin's wonderful statement. You can have data without information, but you can't have information without data. We're going to take this one step further now and figure out what do we mean by intelligence in most cases. And while we have information that we supply data in response to requests for, we also have the idea of how is this information used at the strategic level. So strategic use of information is where we get into intelligence. Although, as you can see from the bottom of this chart, this definition was created in 1983. So many, many moons ago, and we've used the words knowledge and wisdom up there in support, in replace of intelligence in that context here. So this chart here has been around for a while. It's a very good objective way of describing these three concepts. And these concepts, of course, altogether combine to form a model for us. Now, let's talk specifically about a data model, and I'm going to call it at first a data structure. So we have a standard sort of computer science-y definition here, which is an organization of information in memory for algorithmic efficiency, such as a queue or a stack or a linked list or a heap. I won't read you the whole thing there. You can get the picture of it. And you can see it's important to have this because you may need to order your data in certain ways. You may need to change these lists around. You may need to identify them and discover that there is just one and that you want to attach it. I had a phone company I worked with once that did not have a single master data for all of their phone numbers. So when a customer's long distance bill was applied, it might go to the right number, but there were actually 3 of them in the instance that we modeled for management. And that was, of course, a problem for them. The key for this, though, to look at something fairly complex like a data structure is how many of these do you want? And the answer is quite simple, as few as possible. Because you see, as you look at how many interfaces that are required to resolve any type of integration problem, in this case, we're just talking about 6 different pieces of application code, which means we have 15 interfaces. The formula is n times n minus 1 divided by 2 in order to come up with this. This is a very crazily increasing problem in this situation. I'll give you an example. The Royal Bank of Canada told me I could use their numbers. These are old numbers. I'm certain they aren't correct anymore, but they had 200 major applications and about 5,000 connections between the 2 of them. Now, let's just take a quick look at that. If we look at it on this complexity scale, you can see that if I have 200, the maximum upward theoretical complexity I could have is 19,900, almost 20,000 interactions in order to do this. Royal Bank of Canada is down here, so they have only 5,000. Well, this gives us the idea that we have to use models in order to understand, to make the computers understand, and to make the business and technical people understand what it is we're talking about as we're trying to leverage our data in our various practices. And I'm going to give you a little bit of a complex model. This has been called the washing machine model for obvious reasons. First of all, when you are modeling, there are a couple of ways in which you need to characterize your model before you get started. One, is it an as-is model, or is it a to-be model? The to-be model, I put a cloud on it. It doesn't mean that it's in the cloud. It means it's aspirational in nature. So that's the first differentiation. Is your model reflecting current reality, or is it reflecting your aspirations, where you'd like to be? Here's another way of looking at that same set of models, though, dividing it up into 2 types of categories, in this case called validated and unvalidated. That's an important distinction. We'll come back to that in just a little bit. And one more layer of complexity under the whole thing, of course, the conceptual, logical, and physical. And when we look at all of this, what you see happen is that people understand these models from a paper perspective originally. Conceptual is going to be some sort of a narrative or an enumerated list of specifications for the system. The logical is going to be a data model. As Andy said before, it is a entity relationship model in this case popping up. And physical, of course, means the database itself in order to do this. Every modeling exercise that you are doing can be mapped onto a transformation in this framework. And I'll show you a couple of examples as we go through this. Let's take a look, though, at forward engineering, which is the only thing that most students are taught. So you all that are on this call understand that this type of material is not covered in any graduate program, to my knowledge, anywhere in the world. There are certainly classes that are taught in it, but it's not part of a core curriculum. It's certainly not knowledge you would expect a standard IT person to have in order to do this. And our forward engineering should be done with only validated models. If I'm building something off of an unvalidated model, it's probably not a good idea. We can get into that a little bit more in the Q&A section on this. But the idea, of course, is that this is largely related to building new stuff, which consumes additionally only 20% of our total IT spend, whereas enhancing existing stuff consumes 80% of our IT spend. Let's take a look at that, because that is something that is different. And Andy mentioned it before. 80% of organizational time and effort, particularly with data models, is done in a context of reverse engineering. And there is a proper definition for reverse engineering. I was just on the phone with Elliot Tchaikovsky a little while ago, where he was giving a webinar on another group that I'm associated with here. But the idea is, what are the requirements? How do we understand them, and how are they built? But we don't have that. What we typically have is a database. And we start with the physical as is and have to derive that logical as is, sometimes even deriving all the way back to the requirements asset. Again, this is not taught in school, and the modeling technologies oftentimes can be a great assistance in order to do this. So let's look, we've looked at forward engineering and reverse engineering. Let's look at reengineering, which is a term that you'll hear from your management if you haven't already. Reengineering means that you are first reverse engineering the existing system to understand its existing strengths and weaknesses. You may only need to go from your physical as is to your logical as is in that reverse engineering. However, if your requirements may have changed, you may also need to go all the way back and use this information from the reverse engineering of the requirements to inform the design of the new system. So two options here. One, you can go blue arrows, yellow arrows, and then back to the green arrow, or you can stay straight with the blue arrows if you are certain the requirements are not changing. Now I'm going to flip this model on its side for just a minute here, just to show you all this represents and maps directly back into the standards body. So if you go to the Wikipedia article that I show you right there on this, the ANSI standard model of this, the conceptual view is the community view that we see in there, and the physical representation is there as well. They don't tend to show the logical view, and Andy mentioned it before. We discovered after the standard was created that you really do need a logical perspective in order to look at all of these things. So the conceptual is how everybody in the enterprise believes the data is used, and it's their understanding of it. The logical one is that translation function to take you from the on paper, the thing I showed you a few minutes ago, to the actual physical, the plan to get from how we go from one to the other. And so when you're doing this, we should be able to change the physical implementation of this without affecting the user's perspective in order to do this. So let's take a look at a modeling example that has nothing to do with data models very briefly. And this is the Malau Viaduct, the highest bridge in the world as of 2007, one of my favorite pieces. And if you look at the little yellow there, that shows you the route that you used to have to take in order to go from place A to place B. So they used conceptual models in this. And the model that you're seeing on the right there is, if you want to drive the orange path that goes all the way around, it's going to take you longer and it's a slower route. Whereas if instead we produce this highway that can go in, it will now achieve business results and help out in particular for the towns that are located along the edge of the highway, as development tends to around the world. This is a business focused model. It's really typically focused at the entity level, and we're just trying to show how things are related to other things that are in there. Sometimes these models are maintained, but rarely are they maintained in order to do this. So that's conceptual models. Logical models, when they were building this bridge, one of the things they said was, we're going to put in these towers that are here. You can see them across the bottom there, but there are what they call temporary piers that they're going to use in building this. Now notice the bridge is held from the center, and the bridge is suspended from the center there with traffic on each side of it. These logical models can be developed all the way down to a third normal form level, but let's wait on that for just a little bit. Again, we'll see some tailoring options that happen, and it allows the organization to figure out and say, oh, you do have a good plan that will get you there. Now, for you all that are listening to this, if somebody comes to you and tells you they have a plan for implementing the data and they can't show you a logical data model of how that is supposed to work, and that logical data model is not understandable by you and technical people and the computers, you have not succeeded in terms of what you're attempting to come up with. Finally, the physical models have two basic purposes. They become the blueprints for the physical construction of the actual solution here. And again, remember I told you these temporary piers, notice they're in red. As we look at them on the screen here. The real bridge pylons are in gray, but the red are temporary. And what they said they were going to do was to move this bridge across. So they said, how are we going to do this? Well, the other part of this is these blueprints are used for maintaining the bridge. And so even though the bridge was constructed in 2007, it's obviously more than 10 years old at this point, heading towards 15, almost 20 years as we get down the road. Where do we go to check out on things? And you will see this happen in any sort of disaster recovery or whatever, looking at this. So the physical models are critically important for this as well. And I want to just show you one more little piece of this, which is that as they were selling this bridge, they had to say, how are we going to build it? So remember the temporary piers, these are the red ones that you see in this little animation here. And when we look at what's happening here on the bridge, these pieces will be brought out across the overall bit. Then we're going to put them on these little mechanical movers, and these movers will move the bridge very carefully, pieces, and they do it by lifting it up, so they don't put any angular pressure, any sideways pressure on those particular pieces. When we get it up, then we can let it down, go back, reposition the dragger, if you will, and do it again, moving that bridge 2 feet at a time in order to complete this wonderful bridge, which is also, by the way, held in place with a deliberate amount of welding to make sure that you have structural integrity on the bridge here. And again, remember where we started just a few minutes ago with our as is versus our to be. So let's switch back into data. When you're doing data modeling, we're doing details. And these details are organized into larger components, but the details are very intricate in nature. The larger components are then organized into the various models, which introduce dependencies as we go through. And you'll see this as you can't use a website until you register for it. I mean, a very simple one in order to do that. And that these models are then organized into architectures, which talks about purposefulness, mission orientation, et cetera, et cetera. In the data world, of course, it works the same way. We have attributes that handle the intricacies, the data models that handle the dependencies, and the architectures that handle the purposefulness. So why don't we ever see any data architecture models like this? The answer is because they're too big. You can't do this by hand. You need to have tools such as Andy was describing in order to do all of the work around this. Modeling is iterative in nature. The data models, the architectures are developed in response to specific needs. So the organization has a need to modify or create a new model. And you already know now, 4 times out of 5, it's going to be to change an existing model in order to do that. The data model then authorizes and articulates very specific information system requirements. Now notice one other piece in here, which is a bit that we forget to mention a lot. And that is that we also have to have some sort of a trusted catalog. That is, of course, built into the various case tools and things. However, if you don't have a case tool, you still need to start a catalog. By the way, that catalog is the data governance glossary. They should be the same tools if we're working on them. And of course, if we do a poor job with all of this, we end up with a situation that Hans Christian Andersen, being the world's first data modeler, I'm totally kidding, but he did come up with a wonderful book here called The Princess on the P. And if you remember the story, the P down here at the bottom of this mattress is affecting the princess's sleep up here. What does that mean for us? Well, they didn't have a catalog in order to do this. Typically, these are undocumented, which means that if you do a poor job with the data modeling, you fail to understand the role of data governance within the proposed and existing services. Actually, it doesn't strictly to data governance. I just happen to have that particular word up there. But when you have that P, you've locked in those imperfections for life, and it restricts additional data investment benefits and decreases the leverage that you can have in your organization. We spend 20 to 40% of our entire IT budget migrating, converting, or improving our data. And if we try to do it faster, it will take longer, it will cost more, it will deliver less, and it'll present greater risk. Thank you very much, Tom DeMarco. Or another way to think about it, we're simply pouring sand in the highly functioning gears that are in our organization in order to get this to run. So let's take a couple of quick examples of how data can be stuck in bad ways. Here's a very simple example. This is the iTunes, formerly iTunes, excuse me, music database on Apple computers. And it's showing you what somebody might have put together if they wanted to maintain your music collection that you have. In order to do this. I'm going to ask a very simple question. I'm going to go through these very quickly. Remember, this is all recorded, so you can come back and review it at your leisure when you get the slides. But if I deleted record number 1, what would be lost? The answer is deleting record number 1 will do two things. One, we'll lose the fact that I purchased the song We Met Today, but we also lose the fact that We Met Today costs 99 cents. And that is usually undesirable and unintended. Let's take it, that's called a deletion anomaly, by the way. Let's take another example, an insertion anomaly. There's just 3 types. Suppose I want to add a song called Scuba, and it costs $1.29 to this existing data model that I have put up. Well, I can't do it until a purchaser buys the song Scuba. So that is, again, unintended. We can't insert a full row until we have an additional fact about that row. Unintended, undesirable insertion anomalies. We also have update anomalies as well. Again, let's say that I just wanted to increase the price of We Met Today from 99 cents to $1.29. Well, the answer might be to change the data items such as song. I would have to read every row in this entire database in order to go all the way through it. And if I read all of them, even so, I still might not get it right because I would not catch the spelling error of We Met Toddy. They even spelled it wrong on there, but you get the picture on that. So there are good ways of organizing data. It can be optimized for flexibility, adaptability, retrievability, risk reduction. And there are some techniques that we can use. You probably have heard the phrase smart code's good, smart code's bad, dumb code's good, et cetera, et cetera. The key to all of this is that it should be done as much as possible to store one fact per row. So again, row 2 is an example of purchaser number 1 has bought sushi and it costs 99 cents, but these are 2 distinct facts and we really should keep them in 2 completely separate tables. So let's dive into the various modeling types now. In the conceptual one, we should be talking about architectural trade-offs and strategy. And of course, we should be introducing the glossary at that level. So here's our washing machine model. We're just on the left-hand side. The pink stuff is the conceptual model. It can be validated, not validated, to be, or as is. In this case, the motivation is to standardize and harmonize the vocabulary I've mentioned before between the business and technology, but also between the humans and the systems. To focus on the strategic trade-offs, to provide specifications providing the organizational strategic data objectives. Data is used to support the organization's achievement of its strategy. And these requirements should be demonstrating how you are going to satisfy the business objectives. Unvalidated models require the word draft on them. And I urge you to put the word draft on any model that has not been validated. You'll be amazed at the kinds of things that you are doing, because what you're telling people is, I think this is the right answer, but I'm not 100% positive. Fingers crossed we'll move ahead, everything will be okay. Well, I wouldn't fly in airplanes if they ran that way. You shouldn't let people do data modeling in that. Again, these conceptual modeling models help us to understand the various organizational concepts and hypothesize about how these data things relate to various other data things. We may need unvalidated ones to understand and just do some brainstorming, but we may validate them as well to understand the various data pieces to go around it and understand what system-wide definitions are. Architecture is always going to involve these trade-offs, and so should your conceptual models. Good, cheap, fast. Pick any two of them is a back of a business card that a friend of mine has used for many, many years around all of this. Let's dive into the strategy for just a quick second here. The old word for strategy, and I say this, comes from the military context. In about 1950, you can see it started getting used more. And when it was used more, this was because the business environments got it and turned it into a master plan. Well, strategy at that point became a thing. The original concept of strategy, and the way I prefer to use it, is that it is a pattern in a stream of decisions related more to process than to a thing. So the idea of strategy is that it's something you can get good at as opposed to something that you write perfectly in order to get it done. Let me give you three very brief examples. First of all, Walmart's former business strategy is very simple. Everyday low price is known by everybody in the business. And they've done an excellent job of making sure that you understand that. If, on the other hand, you're a sports fan and you ask the question, what is Wayne Gretzky's strategy? How to become the hockey great that he came to? He's got a great article in Wikipedia as well. He skates to where he thinks the puck will be. After all, if you're chasing a large a large plastic object on the ice, it's going to be much faster than you are, and you will be unable to keep up with it. So you have to position yourself to where you can correctly take advantage of it. Third example here is a little bit more complex. I need to set it up for you. It's Napoleon at Waterloo. How do I defeat the competition when their forces are bigger than mine? And the answer is divide and conquer. So what does that look like from a strategy perspective? Well, remember, strategy is a pattern and a stream of decisions. And as a complex strategy, this is actually kind of awkward. First of all, we're asking low-paid soldiers to hit the armies just right at exactly the right spot so they separate. Then we're asked all our soldiers to turn to the right and defeat the Prussians, and then turn to the left and defeat the British. And oh, by the way, while somebody's shooting at you the whole time. So complex strategy is generally not a winning piece to go on. Data models are used to support strategy. Here's an example that I experienced directly when I was much younger. I was a manager of a store, and we were going through a recession. If you guys remember the first oil recession crisis in the late 70s, or actually mid 70s, I think it was. They told all managers that they had to sell. Well, here's a situation where you can see from this conceptual model, I'm either a salesperson or a manager, but I couldn't be both. And consequently, it was very difficult for this organization to track sales from their managers. Not that I was a great salesperson as well, but doing that on an entire store-wide basis made it very complex for the organization. So when we look at strategic use of models, you can see that Sabre created the entire flight booking business based out of a data model that they are still using today. AT&T invented a brand new credit card business overnight, again, using the same data models that they are using today. Amazon is using the same retail models that they invented when they were starting out 20 years ago. And Capital One, of course, reinvented the solicitation algorithm around all of these. So how do you go about putting together a model? Well, again, the data modeling process is you identify the entities, you identify a key for each entity, and a key is a way of identifying one specific record in that list of records to the exclusion of all the other records that are associated with that particular entity. Start drawing a rough map of what the relationships look like. This is where you get into the trade-off that I was describing before. Identify the attribute values. You should have a list of those from your system already. If you don't, you're too far in your systems development practice and you need to go back and do some more requirements and allocate those attributes to the various entities that we have, mapping them back and forth. Of course, don't forget, all of this has to keep up with our glossary, our dictionary, whatever it is we're going to call, the way we're going to all speak the same language as we go through this exercise. Now, model evolution is good at first. You should come along and refine your original model. If you're not, you're probably not paying enough attention to it or devoting enough time to it in order to do this. But if your model is changing a lot and a lot and a lot, and it doesn't stop changing, you do not have a good understanding of what it is you're attempting to do. You may, in fact, add some additional relationships on it in order to take a look at it. Here is a conceptual model, excuse me, I put that up the wrong piece there, for a Department of Social Services that we have here in the state of Virginia. And you can see here the model is just simply describing the entities in this case. That's not to say that you shouldn't have additional attributes in them, but each part of the model, from a client's perspective, from a governance perspective, from a program delivery view, from the vendor perspective, all are different. And when we put them all together to come up with that conceptual model, we now have a good representation of the major things that our Department of State Social Services creates, reads, updates, and deletes data about as it's trying to go through and help the people of the Commonwealth of Virginia in order to do this. I mentioned one more time again the business glossary. It's the start of your enterprise taxonomy. It defines the initial entities that are in your conceptual data model, and it's how you engage the various business entities in order to pull all of this together. And I want to tell you a brief story about this because these are crazy hard to implement. And a story about Nokia, a company I had a long association with, really interesting organization. Started out before I got there doing tires and rubber products, consumer electronics. When I got there, they were doing mobile phones. And it turns out that the Finns are bilingual. All Finns learn both Finnish and Swedish because 2% of the population speaks Swedish. And Nokia wanted to play internationally, so they wanted everybody to learn English on top of that, which meant they had a lot of unknown words. First thing that Nokia did was make it absolutely clear and encouraged by giving people rewards for asking questions. It was not a bad idea to put your hand up in a meeting and say, I don't know what that term means. But interestingly, after I got there, they decided they had wanted to build a good common vocabulary. So when an unfamiliar term was used anywhere in Nokia, the group would instantly turn to their laptops and access the NTB to see if there was a golden or a standard definition that was used. Now, if the term was not in their NTB, they would then take a quick vote to see whether they thought it was important enough to include it in the NTB or not. And the NTB group would then look at the submissions and create new versions of the NTB. By the way, NTB stands for the Nokia Term Bank. So they had a wonderful way of doing it. Everybody understood this, and I'm just going to give you an example of how this was. When I arrived, this was one of the first things that we saw. And I took out my non-Nokia phone, which was a faux pas just for starters, and took a couple pictures of it and said, you know, I'm not sure quite how to describe this thing. And somebody looked at the picture and said, oh, that is our cruiser collector. Well, unfortunately, I was able to go in front of their C-levels in just a couple of hours and say that they had more documentation on how to maintain their rubbish than they did on how to maintain their data. So let's move now from the conceptual to the logical. And the key in the logical piece is trying to motivate simplicity of both operational and design considerations, moving towards standards as opposed to standardizing everything. And here is where business actually meets the strategy. So again, we're now out of the pink and into the orange here, all right? And take a look, again, motivation-wise, it provides specification about the information about the effort, such as size, shape, provenance of the data, the various functions, what downstream uses might the data have. It frees discussion from technical considerations that are separate from the business objectives. And this is the reason for logical modeling. We discovered that it was great to theorize about something, but that theory needed a lot of implementation to get there in practice. So the logical modeling sits between conceptual and physical in order to let us understand and document these various data design considerations that come up there. The design consideration should satisfy specific business objectives, and mostly you should be trying to generate this stuff as much as you can instead of hand coding it. The logical as-is models challenge the conceptual model. I've seen many times where a logical data will cause somebody to go back and revise their conceptual data model as a result of increased understanding of both the existing system and the business requirements that you're attempting to do. You need to explicitly incorporate information from the existing components in order to understand this. If you're looking at a modification to an existing system, it is impossible to do this well unless you understand the strengths and weaknesses of the existing system. The 2B models serve as an organizing principle around which the data capabilities are built and gets us to that common vocabulary. Something else that's very critical to incorporate in all of your modeling types, but particularly at the logical level, is that definition reporting does not provide context. So if you ask somebody to define a bed, they'll say something you sleep in, and that is simply unhelpful. Clive Finkelstein taught me a purpose statement incorporates the motivations in here. So don't let people define things. Instead, make sure that they describe them with a purpose statement. So the bed, great, let's go. Here's a purpose statement. Why is the organization maintaining information about this business concept? Well, it's a substructure within a room that is a substructure of the facility location. It contains information about beds within rooms. A little better. We actually found out a little bit more information on this, and I'll tell you how that goes in just a second, but let's look at a couple of attributes in here. It's a partial list, it's not the full list, but what you can see here is that we now have the bed gender to be assigned. So we know we're going to maintain certain types of beds that'll be assigned to females versus males and everything else that we need to pull into that category. Also, we've got the association in here as well. And again, that's a very crude way of saying a room contains 0 or many beds. Now, what was fascinating about this particular example, this was actually a military health system example. The idea was that they were going to use the beds to track the patients. So you can see the bed has wheels on it in the upper right-hand corner there. But the idea really was not well thought out, because as soon as we pointed out to them that the bed would be pushed into the hallway in all cases, what room was the hallway going to be? Or better still, if they figured out a way to create a room number for a hallway, then the question was, what room number was the elevator? Because that's the main place that patients get lost in hospitals, is the elevator on that. Also, of course, we want to incorporate the status of the entity, whether it's a draft or whether it's been validated in order to do that. So let's take a couple of examples, because we're now looking, not just saying these two things are related, but we're asking how they're related. So bed to room, well, what is that? Well, all right, a bed is related to a room. Interesting information. Here's another one. A bed can be put in many rooms. Many beds can be related to many rooms. So there's our wonderful many-to-many relationship that clearly needs to be resolved at some point. Here's another way of refining that particular process. Oh, okay, many beds can be associated with one and only one room. And of course, that works only until you add a temporal dimension to it. Now you have a really complicated model that gets in there. Many beds may be contained in each room, and each room may contain many beds, is a very precise data requirement specification. And what if these beds can be moved? We now have another level of misunderstanding in order to do this. The various types of relationships are called cardinality options: exactly one, one or many, eventually one, which is a time-based concept, 0, 1 or many optionally, and finally, eventually one or many are the various options that you can have. Again, at a logical model, it's not critical that you be perfect with these, but it's a good place to start adding these associations. Here's a little bit more of the model. Again, we've got the associations. Remember, we're doing all this within the trusted catalog in order to do this. So now we're looking at rooms, patients, and beds in here. And you can see the bed is placed in one room only. These occur in pairs. Reading it the other way, a room contains 0 or more beds. The other paired relationship in here is in brown. A bed is occupied by 0 or more patients. A patient occupies 1 or more beds. These precise business specifications are the P's in the pod that I was describing earlier on, that Hans Christian Andersen understands around this. Here is an actual data model. It's from our DIMBOK body of knowledge in order to take a look at these things. Gives us a lot of ideas how all of these things come into play. And this becomes reference material that we use going for everything else. Now, let's move from logical on here down into physical as well. Again, very bottom of our chart of the washing machines, they can be as is or to be, validated or not validated in order to do this. From a motivational perspective, what we're really talking about is the specification of production systems with entity relationship diagrams and the glossary. All data models are incomplete without the definitions, which means you have to have them done. Now, the question here real quickly is that most of the tools of today will generate this data definition language for you instead of hand coding it. So please don't take the time to do that if you have access to these tools. These blueprints become the maintenance for the future solutions. and can be foundational for the system documentation. They're required to access the data in the system. You need that data model to figure out how to go get it. All of these specifications can be generated semi-automatically. Let's take a look at how that works. Again, these are lists of organizational persons, places, or things that need to be created, read, updated, deleted, and some people add the words archived into that as well. Again, just to look at one example here, we've got clubs and regions. So we might look at how these two are related. Here we have a club ID that we're putting in place. So that's how we identify a specific instance of either of them. And clearly from a regional perspective, we're looking at some weather type related, right? Well, I'm not sure exactly what type of club it is, but clubs need to be uniquely identified based on this particular piece. And we're going to maintain some club specific information, tables assigned, reservation. Again, not any particular example here, but you can see just as the basis of this physical model, it's a 2B model in this case, each club must be part of a region. It cannot exist without doing that. And these uses then give us the idea that we should now talk about which specifications we're going to put in here. So all clubs can have a status. There can be many reasons for the reservation, but it's a free text field, and that may give us some data quality problems as we go forward with all of this. The model level variances, addition of keys, definitions are all relevant. They can apply at conceptual, logical, and physical levels. They typically are more detailed as you get closer to the implementation process that you are working within in order to do this. I'll give you just a couple of quick things here. These are the basic database structures that you have: a flat file, an indexed file, a network database, a hierarchical database, a relational database, and then of course all of the other, whoops, I'm sorry, I'm going to go back on that. Again, flat, indexed, network, hierarchical, and relational database, plus a whole bunch of new ones. And this is where it becomes very challenging from Andy's perspective to be able to be responsive to all of these types of data models. And I see we've got a couple of questions already on some of these, which will be great when we get to them. These basic structures, however, allow us to understand the basics of the system. So here's a system that we used at Virginia Commonwealth University called the Student Database Master. And while you may not understand a lot about this particular database, if I tell you that the parent entity has been circled in yellow in the upper corner, and it's called, funny enough, SDBM, and that every other entity on here is a child attribute of that SDBM file, you now have a pretty good idea of how this system works. This is a real life example, by the way. We replaced this system with our banner system, but one of the other vendors tried to sell us this 2B data model. Now, if you can't look at this and say, oh my goodness, this is silly, we've failed miserably in our little attempt at education here in order to do this. This is, of course, a poppycock model. It makes no sense whatsoever, and the people who were involved in it narrowly escaped going to jail, but that's another story entirely. Here is, just to finish out the concept on physical, this is looking at, this is PeopleSoft actually. The HR model in PeopleSoft looks like this at the conceptual level. It looks like this at the logical level. Notice our goal for simplicity, but when you implement it in Oracle, it gets very detailed. And again, I'm showing you these slides just to show you up detailed how this model goes through all the various bits and pieces in here in order to look at this. So we've taken some time here today to look at modeling and giving you some motivation, which is that we have to have 3 different modeling types depending on what you're attempting to do: conceptual, logical, and physical. Plus the 2 characteristics of, is it an as-is or 2B model, and is it a validated or an unvalidated model? There are reasons for doing each type of modeling, and those reasons should be driven by your business needs. So make sure that you write at the top of all your models, we're doing this modeling because, right? So we've got conceptual models here, again, architectural trade-offs that we've talked about, and we introduced the glossary at that point. The logical models, which should be simplicity oriented, give us an opportunity to harmonize, to standardize, to make things as simple as possible to avoid the enormous complexity of all this. And then our physical models, which actually become the blueprints of what we're doing. So as we're headed towards the Q&A, I've got a couple things to sort of summarize where we are and wind up on this. And we'll invite Andy to come back and join us for the discussion. There's correct ways to organize data. All of these correct ways to organize data involve data modeling. Again, it can be done for flexibility, adaptability, et cetera, et cetera. And the techniques include smart codes good, architectural joins, et cetera, and avoid, if you possibly can, all of those keys that get into the design, because most people have not been trained in data modeling in order to do this, including the ones who produce our commercial software in many instances. Similarly, as you're working through this with organizations and groups, don't tell them that you're modeling, just write some stuff down, right? It's not hard. Jot some things on a piece of paper, then go back and arrange it and make some appropriate connections between your objects. There's lots and lots of different ways of doing this where you don't have to make it a formal exercise and scare everybody that you're doing something technical that they may not understand. So I like to tell people the reason we're locked in this room, the reason you guys are spending 90 minutes with us today is hopefully we're delivering some value to you about these different types of modeling techniques on this. So the reason we're locked in this room might be to understand the relationship between customer and soda. And our outcome that we're trying to achieve is to be able to walk out the door with an as-is physical and logical model of this relationship. So it might be soda is given to customer and customer selects soda. Oh, wait, we've forgotten the original specs to pay for it as well. Yes, I did see that in one particular instance. People, yes, we're just going to hand them sodas if they ask for it. Again, what's the relationships? What are the different characteristics between our hospital beds? We want to walk out the door when we've identified the top 3 characteristics that represent our brand of hospital in this and how our hospitals are going to take care of this. So if we decide that the purpose of this is the primary means of tracking a patient and we're going to do it with a bed, as you can see, if you had any time at hospitals, you know they now barcode you, so you don't need to worry about being actually in a bed, which if you think about it, makes a lot more sense. But in those days, we didn't have the ability to barcode individuals around this. One final example on this, again, just as our focus, could our systems handle the following business rule tomorrow? So we're in the middle of the Great Resignation, we're having problems. Can an employee work at more than one positions, or can a position be filled by more than one employee? Well, if we look at our existing as-is data model, we can figure out for sure that a position can be filled by 0, 1, or many employees. That means we do have the ability to do job sharing with our existing system without making any specific changes. These are all examples of where we use data modeling to answer specific business questions that came up during the course of maintaining our systems or creating new ones. But remember, the ratio on that is 1/5 new things, 4/5 at understanding existing things. So the key for data modeling is to obtain some business value. You've got to have a good series of understanding here. And if somebody shows a data model in front of a group and there are no disagreements, no refinements, that to me means we've had insufficient communication. There is simply no way we can show a data model and everybody will always agree it's perfect the first time. That said, those disagreements and refinements should be easily understood and moved so that we can now start to modify the model to where it's going to work. That the data exchange is automated and dependent on successful architectures. Everything that's happening out there in our world is dependent on high-speed automation. Can you imagine if you had to craft each individual email that you were doing? By the way, each employee in your organization has learned data on their own. And so that's kind of a bad thing. And different topic, that's a data literacy topic, but it is an important consideration. And it's why we have so much variance in it. So modeling definition is a problem defining as well as a problem solving activity. And it's important to keep that in mind. It's one of the main uses that you should have with data. And if you have some things that you're doing with data, you're not doing models with them, you've got a problem. And if you're doing models without the glossary, it's even worse. So you may do different modeling challenges for different problems. You may have use of the model is going to be much more important than any specific modeling method. In this case, the model should be always seen as living documents and should be available in an easily searchable manner. And that the value is derived from improving the data and changing it and helping us go through it piece by piece each time so that we can get better at the process. I also include the use of color and animation in there. It helps out an awful lot around all this. If you want to learn more about these topics, we breeze through them very quickly. There's, of course, our DIM mock. I've already mentioned works that are in the dim box. Yes, that is sideways. I had to get it in there so it would all fit. There, David Hayes' book. Graham Simpson wrote a wonderful book, Data Modeling Theory and Practice. He's also the author of the Rosie Project, if you haven't seen that one. And our colleagues at some other universities have put some other bits together here. Oh, Shannon, I went 10 seconds over. I didn't do it very well. Anyway, back to Shannon and Andy. And thank you guys for listening to all this.
I'm going to note it, the moment that Peter went over. 10 seconds. Well, thank you, Peter, for another fantastic webinar. This is just amazing. I love it. Been a lot of chat going on and questions coming in, lots of questions coming in already. Just to answer the most commonly asked questions, just a reminder, I will send a follow-up email by end of day Thursday to everybody, to all registrants, with links to the slides and links to the recording, along with anything else requested throughout. A lot of great resources in those slides, so I'll make sure everyone gets those. And Andy, feel free to jump in as we get through these questions. So this came in, Peter, before you even started, but we've had three.
On that.
Yeah, three upvotes on it.
So does the NoSQL get to go first?
Huh?
Does NoSQL get to go first?
That wasn't the first one that I was looking at, but.
All right, well, you go ahead. We'll
All right, so conceptual model, define entities, relationships, and capture business data flow. Logical modeling, define keys, full, attributed, physical, data types, nulls, not nulls. Trying to understand where exactly we define keys.
Well, in my concept and my experience of this, and Andy, please feel free to jump in here as well. I want to say it almost doesn't matter. Before you get to a physical, you will need a key. If you have a good idea at the conceptual stage what your key should be, I don't have a problem with noting it at that level and saying, hey, we think this is going to be a key. I would label it as a candidate key if I were going to do it at that point. But if we get into arguments with business people talking about whether a key can exist in a conceptual model, the business person is going to get turned off because they're not going to understand the conversation. So where things fit, just think of them as becoming increasingly more robust as you move from conceptual to logical and from logical to physical. And the introduction of keys can occur at the conceptual level, typically doesn't. So if you showed me a conceptual model that didn't have keys in it, I would not say this is not a good conceptual model. I would say we now need to start working on some keys, but perhaps that can occur at the logical level. So the real key is, again, using the word key, sorry, to do that, what business problem are you attempting to solve? And if you have a conceptual model that says, I want to show the major classes of data that we are going to create, read, update, and delete information about in this system, I'm perfectly okay with keeping the conceptual model at just simply being entities related to other entities. Andy, what do you think on that, though?
Absolutely. There's no steadfast rule with any of this. And I agree that if you're arguing as to what's a key in conceptual and logical, you need to take a step back. But yeah, traditionally you would do it at the logical level, but if that's what the organization wants, and that's how you get the buy-in, right? I mean, maybe you're going to have some discussions at a high level, but like you were saying before, people get a little nervous about even the concept of modeling. So just keep it, hey, this is how all our data is put together, and leave it at that. And that's where we're going to discuss this, and that keeps everybody focused.
And Andy, let me take you to a reverse scenario on this, because we talked about in both of us going forward on this. I've done a lot of work going backwards as well. So when you start out with a physical as is, of course, you're going to start out with a key, right?
Right.
I mean, you can't implement a database with that. And some of the tools that we've talked about do that automatically. So I've actually been hired to come in, and people say, I've got a database, but I don't know what the conceptual model looks like or the logical model looks like. Can you get it for me? And I say, do you have a copy of tool X? In this case, usually Irwin, right? We'll put Irwin up to it, connect it, and 5 minutes later it's done, and I'm out of a job, which is great, right? Because now you've got the information that you actually wanted to have.
Exactly. And that's one of the things that, with our data modeling solution, we can point it directly at that physical structure and create the ER diagram in line. So it'll be an accurate reflection of, what the actual data structure is. And when we show a conceptual model, we're literally just showing the entities and the relationships. The attributes and everything else is associated in the actual full-blown logical model, but we just expose the entities, which there may be keys there, But when we talk about it with the business teams, we're just going to see the entities and how they're related, and that would be reflected in, in the underlying physical structure.
And I'm going to just flip back a couple of slides to illustrate that, Shannon, but go ahead and jump to the next one. So again, here's our physical as is structure, which is very dense and detailed. You can see there's a close-up of bits and pieces of it, but that's not where, again, a business person is not going to be able to relate to that diagram at all, whereas they more likely are going to be able to relate to something here at the logical level.
Exactly.
I like it. It's the key to keys. You mentioned a question earlier that came into the chat early on, how do you model a NoSQL database?
So the first thing to understand about that is that NoSQL stands for not only SQL. So the key there is to say that there are some pieces of SQL that can be used to model very, very easily. Again, the DDL that is in there can be fed into these various case tools, and they will pop out a model based on what the SQL is. So if the SQL is very specific, it will have lots of information. That, of course, does not represent the totality of your not only SQL database. And the question comes up of what other blendings are you pulling into place? Are you doing a fully indexed piece like a data lake kind of a situation, or are you doing columnar databases? How is that organized? So it goes back to the question, what are you attempting to do? Don't look at this as the logical definition must contain the following things. Look at this as what answer am I trying to come up with? And if my answer is how is this data arranged internally, you can get some very good information from pulling that out, because of course, not only SQL is going to include some SQL, and that's the best place to start off with this. Andy, how would you add to that? And there's probably several other things besides just NoSQL that we've talked about as well, that I know you guys have seen some more exotic data structures these days.
Sure, that's a great question, because we just added support, full-blown support for NoSQL starting last year, and it was probably the #1 requested feature in our solution. And shortly after it came out, there was a lot of questions. Why am I even modeling this? And it's a document, right? It's already documented for me. Well, you're going to have those JSON structures are going to be part of the overall data flow. But even more simply, if you're talking about any sort of compliance, the information that's in those documents needs to be governed. So the way that we can work is, like we were saying before, you pointed out that data structure and create your model, and then identify what you need to be watching, identify your personally identifiable information and anything else that may be contained in those documents, because in the DevOps world, these structures are changing very, very quickly, and they're designed to do that. So being able to model how that is set is, how everything is set, and then be able to govern it, identify the objects that are out there. In addition, what we do is with our data modelers, we can denormalize, which breaks all of the rules. I was just at MongoDB World 2 weeks ago. I think, well, it was about 3 weeks ago now. And one of the features that I kept on showing was the denormalization of your relational models. So if you want to, or if you're moving into a NoSQL environment and you want to maintain your relational structures in a NoSQL structure, you can take your models and then denormalize them and convert them into JSON as a structure, or into MongoDB or Couchbase or Cassandra, any of those structures. So having that model as to how everything actually exists today relationally, and then denormalize that into an unstructured data, you're starting from a single point. And if you try to do that yourself, if you try to denormalize everything that you have, well, first of all, you're going to cringe, because you've been working towards getting everything into the third normal form for the past 30 years, and you're going to make a lot of mistakes, intentional or unintentional, right? So having a model to start with is your starting point. And then you can denormalize out into all these new structures with familiarity of what exists today.
Let me add one point to what you said, Andy, too, and that is that many people say, well, I don't care what the existing structure is because it sucks, right? Well, okay, sucks is not a very precise, word in there. And I will stipulate that all systems do some things well and some things poorly. But if we don't know which ones are which, how are we going to avoid making the same mistakes? So this is the reason for looking at reverse engineering in this fashion, to say we really do need to understand these things, because if we don't take that information that we have from the existing system and understand it. Again, my favorite example is the old hard drive. I used to put on one hard drive A through D, and on the next hard drive, I'd put it on the E through J, and you know, blah, 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 divide up the alphabet that way. Why did I do that? Well, because each hard drive was 10 megabits in size, and I couldn't put any more data on it. Well, that's a really bad reason to carry that design forward. So how can we do that in a new environment where we've got tons and tons of practically free storage? Well, again, it's got to be done in a programmatic fashion. And that's, I think, the point that you emphasized, Andy. Not that everything can be programmatically done, but more and more we are learning how to put programmatic things in here that'll help translate those XML structures and other types of activities within that.
Absolutely.
So back to the question of keys, also from the same questioner, original questioner, also facing another issue in logical data modeling. If we have a similar business concept with different primary keys, how do we represent this same concept in logical data modeling? Initially, I thought this should be like supertype and subtype, but the rule for supertype and subtype is to have the same PK. So how do we define these in logical data modeling? Parent-child?
There's probably some sort of synonym or other types of redefinitions that you find. I see this in insurance companies quite a bit, where the same concept, people will think it's actually two different things. And you realize if you look at all of the attributes back in, by putting them in a data model, just exactly what we're talking about here, and comparing them, you'll find out that the two things have more similarities than differences. And that there's probably a variant on that that will allow you to fit into some relatively normalized type of structure around this. Andy, I've certainly seen bunches of instances where organizations come to me, these are different concepts, and you know, how are we going to model them and how are we going to work together and all. And by the time you actually do a thorough analysis, you find out they're actually more similar than they are dissimilar.
Absolutely. Yep.
All right, I love it. So I'm increasingly horrified by comments made by my colleagues in data architecture that are telling me that with cloud-based systems, we no longer need to waste time on data models for the data lake, Databricks, or Snowflake. Just move the data in and let the business users do their reports and analytics. Are you hearing this too? What are your thoughts?
I hear it all the time. How about you, Andy?
Yeah, and I tend to disagree with that opinion.
Yeah, I think we both kind of cringe on that. But I would say, really, again, back to the 80-20 rule, the hype that has been around this is that what we're describing here takes some time and to do it carefully. And most people say, well, we don't have the time to do it. We just need to get the data out there. Well, you know what that does? That enriches your cloud vendor. It's like deciding to fight in a divorce, right? You know who makes money on that? The divorce lawyers. Yep. And then if you throw anything up into the cloud, you're going to end up with a mess, and the cloud vendors are going to be extremely pleased. In fact, I have rules of the cloud. I think that data in the cloud should have three characteristics that data outside the cloud does not have. Data inside the cloud should be of higher quality than data that is outside the cloud. I think everybody would generally agree to that, but you have to actually take some steps in order to make sure that it does happen. Data inside the cloud should be by definition more shareable, and that's an architectural concept that can't be engineered without a thorough understanding of data structures and the taxonomy, if you will, of the organization in order to do that. And by virtue of 1 and 2, your data volume in the cloud should be considerably less than your volume of data outside of the cloud. Now, that is not the way most people approach this. They simply walk up, they take a forklift, and they throw all their data in the cloud, and they make Amazon or Microsoft or whomever it is very, very rich. And now you have an additional barrier of, I can't just manipulate the data directly. I've now got to go through some sort of cloud-based interface in order to do this. Andy, what kind of arguments do you use to push back on people when they say you don't need to model this because it's going in the cloud?
Well, I generally say au contraire, mon frere, and then I'll go into my little diatribe. But the big thing that's being missed if you don't model in the cloud is lineage. And we're talking about modeling today, and but when we're talking about the information that goes into the cloud, where is it coming from and how did it get there? To your point, we want to make sure that we have good data up there. And generally, you know, if we're going to be in the cloud, there's going to be analytics. involve that. And there's probably an EDW, or it could be a data lick. And Bill Inman, frankly, would be very upset to hear that nobody wants to model in the cloud, because that's ultimately the lineage as to where the data is coming from. And with the data modeler, we can manage both your sources and targets and anything else in between. And then you have your established structures at either end, and then everything comes together via your mappings and ETL, ELT, anything else that you're using to move the data into that. So that's the other reason why you want to model both ends of that data flow, so that you will have a better understanding as to what's going up there and how it's being manipulated before it goes into that. If you don't have a data model or a way to look at your mappings in a comprehensive way in lineage, you're just going to be flying blind, and you're just, it's the old GIGO, right? And we're just going to take bad data and we're going to move it someplace else and pay more for it.
Absolutely. And if you think about it, if you've got data in the cloud, but you don't have a map as to what data is in there, you're going to have every individual analyst go through the exercise that Andy just described, which is a real waste of your human capital. What we see in our data science organizations is that most data scientists spend 80% of their time trying to figure some of this stuff out. And you show them a data model, which I fully contend that half of all data scientists out there have never seen a data model, period. And you show them this and they go, oh my goodness, this is great. Why didn't they show us this in school? And the answer is because you were in a rehashed statistical program that somebody decided where they're going to call data science this year. And you can get a little bit more of a job bump from it, but it's not going to help you with business problems unless you've got that connective tissue, the lineage, the provenance that you were referring to, Andy.
Absolutely. Yep.
Data modeling is not dead.
No.
So with external data dictionary and business glossary gaining traction, where column names can be searched, is it better to fully qualify column names? For example, in a table like credit underscore card underscore account, naming a column account underscore number used to be safe, since users always search in context of column and table. However, these days, since users can search a column in Calibra, Alation, et cetera, would it be better to fully qualify columns and call the above credit underscore account, card underscore account underscore number, because there could be other tables like loan, savings account, et cetera, with its own account number?
So this gets to the question of how far can you apply your naming conventions across the various types of models. And again, I'll go back to my PeopleSoft model here at the very end. And you can see that PeopleSoft did not use that particular, whoops, sorry. You can see it, and I didn't show you the slide. Try that again. They did not use the same definitions all the way through. If you're able and in a position to be able to do that, that's wonderful. But Andy mentioned something as we were getting started on this as well. It's really got as much to do, I think, with configuration management as it does for the rest of this. So when you're looking here at the HR conceptual model that PeopleSoft has here, you can see they're calling it skill and address. And they're still using these names here at the logical level. But as soon as we get down into the physical level, we've now got, well, there's an address, but address breaks up into city index and person and address pointers and you know, all sorts of other types of things that are going to allow you to get very much more detailed with this. So I was part of an effort in the military, the US military at one point, where we were going to name everything all the way from conceptual all the way down to physical with exactly the same names. And of course, this was in the days of 8 + or - 3 in terms of our, right. Thank you, Andy. I know you're laughing at least. You know, there's just no way of doing it. You could do it. It would be a code in order to do, but that means everybody looking at this code would have to decipher an 8 or 11-digit code in order to do this. But tools keep track of that detail for you. So you can define something as an alias in virtually all of the case tools, and certainly in Irwin, and say, this is how it appears in the physical, but this is how it appears in the conceptual model. So when you're having a presentation to management, you use this set of terms. When you use the presentation to the DBAs, you're using a different set of terms.
Exactly. Exactly. And we can actually do that through a name standard mapping. Traditionally, it was used, and it's just funny to shift perspectives here, because we've been kind of talking about building your data models to move forward. But the more common scenario that I find is, documenting what's already out there. And with our name standard mapping, traditionally it was used to take a logical object and abbreviate into SQL-ish, as I call it. And what we have now is we can actually do that in reverse. We find a table called cust. We're going to create an entity called customer, and it uses that same mapping through there for the name standard mapping. So again, that could jumpstart this process. And as we look at the abbreviated, the code, as it were, we can quickly translate that to the business terms. And then in addition to that, what we can do is we can make the attributes having the same definition as the column comments. So we could leverage what's already there to build out our business glossary. Now, in some cases, the attribute or the logical business term might have a different definition, and we can accomplish that too.
It's interesting, these models that I'm showing here, coming from the original PeopleSoft systems, we had fully reverse engineered PeopleSoft and come up with a complete set of these models, and we're trying to get PeopleSoft to include them. And I can remember today, many, many years later, Rick Berquist, who was the CTO of PeopleSoft at the time, said, I just don't think our customers are interested in this. And I agree. They generally are not, but that's not his fault, and it's not our fault, but it's the university system's fault. We have not told people the importance of these various modeling, what the various types are, which is why there's so much confusion about them out there. And we've got to do a better job of it in educating both our data professionals as well as our business users to some aspects of this.
Absolutely, absolutely. And I'd just like to add to that, just to emphasize the importance of data modeling in the industry today, is Microsoft's common data model to build out their data lake so that all of the Microsoft stack will have a commonality throughout. And if it wasn't as important as it is, I seriously doubt that Microsoft would have made the investment and the time to build out that common data model, so to help everyone and start pushing information into the data lake that could be used by applications and other data systems.
I will say it has been wonderful to watch Microsoft become smarter about this process. Many, many times in the past, we tried to get them to pay attention to this. I've been in and talked to their enterprise architecture groups and things, and they're very frustrated because Microsoft is very much of a tools-oriented organization. But having the idea here, and I'm sorry, I'm flipping the slides around trying to find the one I was looking for, but I'll just give up on that. But it is correct. You're right, Andy. They've done a great job of sort of getting religion on this and saying, no, there is something that you can put in place and map back to absolutely for the entire Azure stack in here. And that's a very welcome development.
Yep.
So many great questions coming in, and we'll get to as many as we can here in the last few minutes. We got about 80 minutes left. So what do you think of no-code environments for IT application development that generate their own versions of the data they use?
You want to take that one first, Andy? Go ahead. I've got a thought on it. But...
No, go ahead.
So the key with no code, of course, is that it makes it sound like you don't need anything. This is the whole reason for developing some of these alternative models, because people think that this process that I'm showing you on the screen here now takes too long. And that's of course correct if you only do it once. But the key is to remember that this should be the basis for doing your planning. When you start thinking about changing things in your IT environment, the data are the most consistent, the most long running, and the most stable components of your IT architectures. One of the nice things about being on the planet as long as I have been is that I literally have seen organizations that have been around for hundreds of years and they're still doing the same basic things. And I have seen organizations create data models that are still being used years and decades, in fact, later. The one that I'm most proud of that I was associated with was the DoD data model that we created in the early 90s that is still being used today, 30 years later. And that was a tremendous accomplishment that was put together. And that these models have the ability to understand a particular aspect of the business. Data modeling is not going to answer certain questions. It's a way of answering certain data questions, but there are other types of questions it's not going to address. But many other types of documentation have been developed and are used in these areas, but for some reason, there's just been a dearth of information around data, and we need to get better about this whole process. Again, just take the idea that half of all data scientists don't even know what a data model is, and you start to get an idea of how serious this real disconnect is occurring.
Yeah.
When you see no code, it's generally an idea that people are saying, look, can we get some predefined components to put out here? And I love to tell this particular story. I'm a QuickBooks Online user, and QuickBooks Online was in fact developed from the QuickBooks Server models in order to put out. But interestingly enough, in the QuickBooks Online, there is a kind of a missing key feature that a lot of accountants are really mad at QuickBooks about. And that is that there's nothing called a transaction ID that is accessible to users. So for example, somebody who's looking at a book might want to say, I want to follow this transaction back to the journal so I can see exactly which columns it hit and how it was processed internally. And in QuickBooks Online, you're not allowed to access that feature. It does not exist because it didn't physically exist in the server versions, although clearly it has to exist, or QuickBooks Online or all of the QuickBooks pieces could not function. So it's a wonderful example of how these things are very, very confusing to people and causing enormous challenges out there in the business community.
Very well said.
All right, so we've got 4 minutes left. So it's see if we can get this in 4 minutes. Sometimes I'm confused with business glossary. It is a place to, is it a place to store definitions of all attributes? For example, if there are 10 tables and each has 10 different attributes, should all the 100 attribute comments exist in the business glossary? And does this mean like the modeling tool should not store the column comments and the column comment should not be exported to the database? Instead, only place every attribute comment should be in the business glossary?
Andy, you want to take a gander at this one?
Sure, yeah. No, you definitely want to store the column comments and export them to the database, because this way we build that breadcrumb trail backwards too. So we'll enforce what's coming from the attribute definitions, if that's the case, and move them down onto the disk. And that will help in the future as you're building new models, or even if you're just maintaining your existing structures, you can go out there and it's going to consistently come back and be in that model. Definitions may change over time too, although they're very, very rarely will they, but there's an opportunity. And then you want to document it on the disk, you want to document it into your model, and then you also want that documentation to exist in the glossary.
I would absolutely agree, and add just one little piece that I think perhaps the user was looking for, and that is, at what level do we start to, in other words, does a glossary include attributes, and does a dictionary include definitions, and where do those purpose statements that Peter was talking? The key to this, folks, is that you want to have one place. If you've got two of them, you've got two watches. And two watches are generally not a very good thing. So regardless of what technology that you're using, every one of the well-done case tools out there will have the ability to store this type of information. And what you want to do is, when you find it through a reverse engineering exercise, make sure it's stored in some place. When you create a new component for that, get it in one place and put it out there. And so I really object to the idea that people are saying, oh, well, glossaries are only for business definitions. You can't put any technical definitions in the business glossary. It's like, all a business glossary is one view into this larger database concept that Andy was describing. And when you add them is when you get the information. If you get the information, add it. If it's not validated, mark it as unvalidated, and you can do something else with it. You understand it's a candidate and be able to move forward with it there. But don't, oh no, this thing says only attribute level definitions, or only relationship level definitions. That's silly, right?
Yeah. Yep.
When you get something factual, keep it.
Exactly. And I got one more question here that, and I guess we can wrap up, Shannon. But from Yusuf, can the process of transitioning from logical to physical modeling be automated? In the Urban Data Modeler, we will have a logical physical model. So you want to look at your entities and you want to look at your tables in that same model. You basically just flip from one side to the other. So we don't necessarily need to derive from each other. When we point the data modeler at a straight data structure, we can create that logical physical model. And very quickly have the business terms set up with the objects, etc. So there's no automation particularly there. It's just basically reverse engineering and creating a logical physical model.
Well, Andy, thank you so much. And yeah, so I'm sorry, y'all. we are out of time there. Peter, did you just want to add one more thing there?
Just going to say that the other part of it is when you're looking at all of these bits and pieces, the tools will pull back as much information as you need to get in order to do that. And you can filter this and say, okay, well, I only want to look at this model view or only these 3 entities or whatever it is. But it's a way of helping to manage the complexity that's on the other side of it. And they just do a fantastic job in terms of managing all that complexity.
Well, thank you both for this great Q&A. That is all the time, I'm afraid, that we have for this webinar. Again, just a reminder to everybody, I will send a follow-up email by end of day Thursday with links to the slides and links to the recording of this session. There was a request for, there's lots of resources there in Peter's slides as well. And thanks to Irwin by Quest for sponsoring today's webinar and helping to make these webinars happen. Andy, it's been a pleasure having you join us this month.
It's been great being here.
And thanks, Peter. Hope you all, and thanks to everybody and all the attendees for being so engaged, and I hope you all have a great day. Thanks, everyone.